Okay, I'm doing something slightly different at the moment. I'm trying to get myself back into coding, and if you hear some whirring going on, it might be because of the fan. I need to keep that on because it's quite warm. Um, so on the screen you can see this set here. You can actually, yeah, you can. Okay, so this is for the Vectrex. This is 6809 assembler. These bits here are basically me defining certain areas that I'm. So basically, instead of me doing this down, actually no, instead of me doing, say, this here. Well, sorry, the draw line D is actually this this call to the Vectrex ROM, but instead of me saying F3DF all the time, I can just define this word and then I can put it there. So that becomes a little interesting. Connecting. Oh, you're seeing connected. Oh, I suppose it's. I'm hoping you all got that anyway. So what I'm doing is I'm trying to make a copy of a way lines. I want basically lines to basically do this, do this, do this, and do this. It's based on somebody else's game that I know that they're doing. So let me just find okay. Let me just on YouTube a second. So let me put on this and change the capture. So this is the game. You see the way that moves and the basically way that the game is drawn like that. That's what I wanted to emulate, just as a bit of a fun thing. And it's got that kind of Tron look, and I thought the Vectrex might actually do it quite well. So let me just back to the other window. So that's what I'm doing. Show you now where I'm up to with it. Let me find where. I'm trying to find the emulator here. Deadless. I know, because it's wrong. Go. You just load up the emulator. Is that displaying or not? No. Let me switch to. So that's what it's doing currently. So what we're gonna do is we're gonna switch to this. Right, so So what we've done here is we've loaded, we basically make a setup first. So this here, actually. So we basically switch to the org for the RAM, because when you put the cart in, I believe it starts from 0 here, but in order to get to the memory locations, we need to switch obviously to where the section where the memory resides. So I've defined stuff here like line A, line B, line C, and this here is for me to change so that when it gets to the top left, I think what I was going to do, I was going to count to 50 and then change it. I think that's what I was doing. I think also this might be an array, and it should be. It's getting me to think about where the array is. So in the code bit, we switch to org 0, then we do the setup, which is, that's the screen, and then we've got the music. So when the emulator starts off, it's got the sign there. We switch back to I'm gonna switch back to a monitor, and then I'm just gonna rebuild the cartridge ROM. Not build the cartridge, what of a change. Why can you build the cartridge? Oh, wait a minute. Yeah, the thing about assembler code is it's very, very picky about what white spacing, which is a bit annoying sometimes. So we reload it, and you can see that's the AOA and that's the title screen, and that's where this is coming in, and then the music is this section here. So you must have this. You can't change the name from GC to anything else, it won't work. But you can change the date here. So the music is set by the ROM, is up there. This is the text for AOA, so you can height and the width and where it is from the screen. And also weirdly the screens, just let me switch back to this. The screen basically, instead of most games doing across and down, this is split in the middle. So 0, 0 is here, and you can have minus or plus. So that's like this with a plus. This will be minus. So this will be, I think it's plus X, possibly plus what? Plus Y. This is minus Y. It's minus X. And that's minus X plus Y, I think it is. So I think that's the way it does that. And then you've got the recal, basically resets the beam to the middle, and then you can start putting stuff in. So here I've done load into register 0, load into another register 0, and then use this, and that moves beam to the relative position, and then you can set the intensity of the beam, so you can have like brighter beam or anything like that. And then we go straight to read, putting the X and Y in, so that's 0 for A, and then line A is this here, I increment it, store it, so it's at 0. No, it's at 1 now. So you increment it, it goes to 2. You store it, and the memory location stack becomes 2. And then here, this is a new thing that I've added. This pushes the B, which is line A, which is now 2, to the stack, so I can save it. And then I draw the line, so I'll draw from 0, 1, and then I reset the line, reset the position. You need to do this one to do it. And then I tell it to move the beam to 1 down, move to D, which is the interesting thing about this. I think it's there's a register called D, and I think when you put the A and Y in, it updates it. Well, I think it's A and B put in, and it updates D as both. So that's where it's reading that from. Here I'm putting this saved stack into the A register, and you're going to try and compare it. So the next thing I want to do is I want to compare line B, which is 1, compare line A, which will already be incremented at this point. I want to say if you get to 3 lines along, or 3 dots along, then start doing this. And then again, I'm going to do the same here, or I'm going to be compare it to B. So then you get 1 line, and then the next line starts, and the next line starts. So it gives it that kind of difference. Hoping that's the way it's going to work. So I need to switch to capture. So at the moment, I'm just checking to see what the jumps are, because there's different types of jumping in different assembler languages. The one that the Mega Drive would use, which is 68K, would use BNEs, which is branch if not equal to. Jumps like are used here. This is a relative jump if I remember rightly. So I think it's a relative jump. I know in a static spectrum, if you use this, you can't. It's like a short jump. It'll jump 128 bytes worth of code or something like that. So you got to be careful with that one on the ZX Spectrum. I can't remember whether, I'm not sure whether the Vectrex is the same. It's probably quite the same. JMP is just a straight jump anywhere. I'm wondering whether, because I want to do greater than or less than, and I had to do it a certain way with the Spectrum, the Z81. Let's see if let me see if trying to remember something here. Large charts. I need to do that tomorrow actually. Yeah, sick. My cat's been a bit penguin.
Going in.
Right. Cat was whining because the door was shut. Now, which file was it that I did? Where I did the greater than and less than? I might have to look up. Might have to go on GitHub actually and just check on my code on there, because the thing, because I've set GitHub up to do Git flow, and what that does is when you set a new branch, in fact it does this in GitHub anyway, when you set a new branch to do something, it will take a copy of what's on the code originally and like fork it off. So and the problem is when you're in that branch, you can return back to the other one. It's just I'm lazy and I can't bother. So I just need to review some code. I still need to remember. I think it was a junk collection one. Because the thing with the compare is it will take one of value away from the other one as a comparison. No, it's not in here. Pretty sure I put it on for inflation. And I'm sure it said if it was greater than calculation of deposition. No. Go to remove that code. Wait, okay, I'm gonna got a better idea. I think I've not merged it in yet. No, it's not in there either. Junk collision with speed, that was. Here we go. To compare stuff, simply do a CP, which is compare. On the Z80, zero flag set than equal, carry flag set less than, N flag set then greater than. Okay. Does the instruction set have that? Seem to do. Negate, no operation, push roll. RTI, RTS, return from interrupt and subroutine. Store, that's store. So for interrupts, testing. Oh, it does have a branch. Oh, it does, right, okay, so BGE bench greater than or equal to BGE. BGT is greater than less than or equal to branch lower. Okay, so what did I say? If I put BLE, so if I want line A to be line A is 2. B I'm gonna try. So sorry, I'm gonna try BLE. Line setup. Line 2, 1. Then so B D and line 1. See if that rebuilds. Okay, so it kind of works, sort of. So I'll show you what happened. If I rebuild the cartridge ROM, you can see that line didn't shift, and then it did again. do actually have on here. Do have another Vectrex debug, and it's massive. It's just like it's like a gig's worth, but it's good for finding out where things have gone wrong. I just need to remember what it's called. That one. Oh, that's the other emulator. Back. Will this show the other one? Nope. It does. Not well. So that's the other emulator I've got, but it's just, yeah. Where did I put? Under game programming by any chance? Yes, I think. I think. The IDE. Let's wait for it to load in. Here we go. And I'll see if I can capture that one. And there you go, that's the this is the ID that's like a gig, but it'll debug stuff. And load in. I'm not 100% on how this works. I vaguely know how it works, it's just very it's very complex with everything it does. Oh, wait. That one. Here you go. So I'll load the ASM file. Oh no, it won't. Let me just try that again. Yeah, there you go. So that'll load that in. But the problem here is this is not the correct code. I now need to new command from you don't need to see this bit, so it's fine. I think what I need to do now is I need to go back to ASO9. Yep, that still works. And I need to change directory and go to in programming. Then Vectrex. Okay. Just that. Yes, I am using LS on Windows because I have Vinsys on this, so it gives me access to Linux commands like LS. Now I need to type in ASO9 while I remember what I'm doing. I think it's ASO9. And then away. I don't seem to have done it. Although it's not as correct as it should be. Let me just remind myself what the settings were. And I need to go to the Vectrex. So if I go to design it, which one did I look at? Programming HTML. Is it Hello World? The problem with the site that I'm on, it messes with my eyes because it's black on standard blue links, and it's just like my eyes just like can't see this properly. Yeah, so to give you an idea of the memory map, from 0 to 7 FFF is the cartridge ROM space, and 800 to C7FF is unmapped space. And if you remember, I was talking about switching the org from C8, yeah, C800, that's the Vectrex RAM space. That's where that code was going. Unlike in like in ZX Spectrums, where you can basically go, here's some memory, or basically here's a variable, go for it. Because this is an embedded system, you have to switch where the RAM bit is. Let me think. Did I say anything? No, it's fine. I suppose because that's not a game, nobody really cares, but that's fine. It's getting me to actually coding this again. What I wanted to do in the first place. Introduction to Vectrex programming. Does this have anything? Memory. Instruction set. Assembler. Yes, there is a source code. Just keep forgetting the commands. I mean, I'm sure I did it correctly, but it doesn't appear that way. That's a screenshot. Recal. Not giving me anything in that one. There we go. ASO9W200H. The hell? I don't remember ever using that. I think I should just be okay with ASO9. Maybe. Yeah, only an input file, that's fine. Let's do something like that because it's not a bin file. This is a bin file though. That's it. It's picked it up now. That's fine. So I need to debug. Now where is the BNE? That's the push for B. That's the one. So do I remember where breakpoint. Breakpoint. Okay, so stop it. That's a breakpoint. Play it. Right, so we're hitting to the first debug, and we will single step, overstep, step out, step out. Where does it run? That goes back. Step out of that one. That. See the register information, and you know what I was saying about the deregister. So that's the deregister there. You got 06. That's 06. 40 40. So when it says move to D, it's picking up for this because we've probably put it in here. And so we were greater than equal to, go back to that label, make that 0. This has changed because it's showing the red. And then we go this one, increment B, so that goes 7. Push stack, that's that there. Back. Draw a line out of that. You can see that moving on. Out there. And we reset this for the second line. Push stack. That should be D7. You can see as that's on a stack. I'm going to compare A. We test whether it's B less than or equal to. Don't think it is. Greater than. Eight. Door. Push. Jump to that, jump back out. jump back out. One in A. D. Push A back in, so that should be 9. 8, yeah. Let's say that one. Line A with B. B should be 0. This is C, it won't contain 0, 0. Long. I think I've done this wrong at some point. I think I'm doing it wrong. I need to go 2 before this starts going. I need to make sure it's 2 or less than. Um, You're doing programming and you're not in the right state of mind for it. But I suppose the good thing about me doing this now is it's giving me something to think about. I mean, it still technically does something. It's just not quite correct. I need to sort something out back in a minute. Right, okay, I'm back. Right, let me just quickly review something because BQ sandwich. I just want to double check something here because right, so it is basically just the BQ and then the loop. So let me just do BGT assembler sign branch. Okay, so we got BG, which is branch on greater than equal, which is what I thought it was. BGT is greater than, which is what I thought it was. BLE is branch on less than or equal to. Yep, I knew that one. Well, I knew. And BLT is branch lower than. So BLE is less than, equal to, or branch lower than. Right, okay, that's fine. I thought. Right, okay, so let me rethink this. Let me completely rethink this. So what I'm saying is compare line A with B. Check it so people can see where I am. So I can switch back to right. So this code is fine. It's doing what I want it to do. This code is fine. It's doing what I want it to do. This code is the new, well, technically this code and this new bit. This is for me to keep the line and then pull it back when I need it to. This compares line A, B, this one, line B. Line B at this point is 1. Line A is 1. Let's just go through this. Line A is loading line A with 1. Increment to 2. Draw that. Push 2. Draw that. Move to the next line. Push 2 into A. Compare 2 with 1. Is 2 less than 1? Yes, it is. Wait, is no 2 less than 1? Sorry. Is greater than, so we'll go back to the line. No, I said less than or equal to. But it's going to be greater than anyway. So 3 will be greater than 1, 4 will be greater than 1, so I'll keep doing that. So I'm wondering whether when it's gone to the far edge, let me have a quick look at that one bit of code. VIDE. Check what it's doing. Turn that one off. That one off. But remember to turn this off now. I'm not used to this at the moment. I kind of get what it is. It's just I'm more of a kind of code on Notepad and see what errors pop up. But sometimes this can be really useful. So where is the turn off code bit? That one? Oh, I see. Yeah, it builds it. And everything goes back to that. If I stop it, restart it. This starts off over here already before it starts moving. Technically, sort of correct. You can see that one's slightly less. And that's what I need to do is so remember rightly, it's one line long. Where's the dice say? Here we go. Oh, sorry, excuse me. Right, okay, so I'm just gonna switch to this one. Right, so in this instance, we're seeing that's 3 ahead of this one and this one, and actually thinking about it, they're all starting at three different lines. So arguably I'm thinking wrong anyway, because they should be on 3 different sections. So that would make this code wrong anyway. Well, technically, I mean, I put it that way just to see whether I could get it all to go on one line, which is correct in a way. So I need to get the X positions different. So the bottom one, the third one, should be this to reset one for line 2. This is a set line 1. Just amend that for line 1. And this sets it for line 2. This should set it for 3. Think. And C, yeah, that's right. So, Y position. This is the X position. This needs to be set for, say, let's put 3. And then let's put this 2. Actually, no, let's be a bit more. Put this for 6. Put this 3. And let's put that 0. That would be correct. I'm just going to double check this with our VGA. Right, so that sort of works. Turn that off. I didn't really want to turn that off. I will show you guys in a second. Let me just find JV. Run from. So we need to go back to this one. First of all, we build it. Fine. And then we're going to need to reload it. Oh, sorry. We need to reload. Bin file. Play it. You can see they're just about that they're all starting at different positions, which is what I wanted. It's at the bottom, which should be further in, which it is. Okay. To give you guys a better idea, switch this over to display. You can actually see there's moved in. So what I'm going to do now, I'm going to go back to this line here, start debugging, stop there, debug this on right, so I'm just going to do this. That line comes across. Right, okay, so weirdly it goes across here, then starts here and moves down. These two shift over. The bottom one comes. The bottom one's coming in because I've put a DNA, I think. Stop, break, stop. Go back to here. I'm gonna comment this line, comment this line, that one. So I'm hoping right, okay. So I'll show you guys what I'm seeing. Need to rebuild it. Back in. And you can see that's all moving and that hasn't. Yeah, because that was because it was the branching which caused the last one to behave and not in the way that I was expecting, which is fine. Okay. So bottom right 50, left top 50-50, because I was thinking about the lines, but I should only really need one, because that figure is never going to change. So that value is never going to change. It's just a testing. So if I make a change here, I say do a compare B. I'm going to do that. Checking the instruction set. So yeah, I can do a compare B. That's fine. So, but sometimes you can't. I think with the ZX Spectrum, I think with any compare, it's got to be A. In fact, let me just double check that. I don't want to be entirely wrong on that one. Z8T set. Where's the compare? Oh no, you can. You can do different compares. So you can do B, C, D, E, H, L, and A. Yeah, no, that's fine. So you can do different compares. That's my fault. On different registers, that is. Sorry. Just don't just confine to the A register. For the ZX Spectrum, the A register is the accumulator where you do all the adding and stuff. So I want to compare B. B has got line A in it at the moment with 50. Alternatively, I could just call bottom right here, but for now, just to test it, I'm going to do that, and I'm going to go BQ equal to no. It might be a bit too much. Sure, there's an NQ. BCC, BCS. BQ is equal to BG is greater than equal to BGT is greater than BHI. Those are the unsigned branches. So BCC is branch on carry clear. BHI is branch on higher than. BLS is branch on lower than or same. And BCS is branch on carry set. Okay. I'm gonna do a not equal. Because what I was thinking of was doing branch not equal. And then branching to this point. As in here. And carrying on. Because it would basically not do the increment. Branch not equal. B&E branch not equal. Doesn't seem to have it. 09. Number. Yeah, B&E does have it. So if I do a B&E on, if I do a B&E here, and I call it skip incline that one. So that will load A with 50. Sorry, that will load B with line A. Check to see if it's got 50 in. It doesn't. That's incorrect. It needs to be if it does. It does have 50. Skip the increment. Otherwise, it should go here. Carry on. So, let's see what Parad JV does this. Okay, that's a bit weird. Oh, I know what I've done wrong. Okay, I'm gonna switch this over. I'll rebuild. So that goes, and stays, moves over here but stays. And these two go, and this is the bottom line. I was expecting this to be the third one, but you remember what I was saying about going up. So this is Y. Gone up by 1. That's this one here. This is line 3, line 2, and this is line 1. Well, that's A, B, and C, sorry. Do I want it that way? That's the question. I mean, it doesn't really make any difference, does it? I mean, apart from the confusion factor. Let's drop 50 to, say, 25. Does the same thing. Is it 10? Hmm. 3. I'm just getting the same effect at the moment. I'm just trying to gauge. Now that's different. Right, okay, I'll show you what it's done now. So I'm just gonna rebuild this. So I'll put it to 3 as a test. Gets to here and stops, but it stops there. Doesn't stop over here, so it's not fully wrapped around. The question is what happens if I do it to 2? It's the same thing. Okay. Maybe I need to debug this. Because I'm a little concerned. Well, not concerned, but intrigued as to why it's doing what it's doing. Because I'm expecting it to stop on 2, but not that long. So we're gonna debug this again. I'm gonna debug it at point D. I'll debug it at this point. So start this. And then I'm gonna they all start, all 3 of them. I'm gonna refresh this. Actually. So at that point, done nothing. First one telling me B's got four, five. It should have stopped at 3, or at least 5. Must have done something real stupid. But that's already compared. B is 6. Give me any information there. Seven. Does it need to change this to a hash? Maybe that's the. So this here. Stop the debugger. Changed it to a hash. Save that. And just have a look at this simulator. Yes, that's what I was doing wrong. Okay, so that's what I was doing wrong. Okay, so I'm gonna just switch to the rebuild the cartridge ROM. Should go a block further. There you go, it stops. Right, so that's what I was doing wrong. Okay, that's good. It's small things like this that you need to kind of get your head into. I think maybe it was trying to look at a memory address or something. That's why it didn't quite work, but I just need to remember small quirks like that. You need to remember for places like on Z80 I can just put 10 in, it's fine. But on this particular one, you've got to put a hash in first to say it's an immediate number or something. I think it's something like that. And then it seems to work fine. So let's rebuild this. I think it stopped at 50, but let me go back to 40 and see whether that's working. Right, okay. If I put this to 30, and then I'm gonna update this and be similar to here. So I'm gonna say this starts out a little bit. I'm gonna try actually doing the same thing. But I'm wondering whether, because this is a little head, we'll stop a little head maybe. See what happens. Like B. That's that one. Save that down here. C. And then copy this. Over here. C. And we're going to see what happens. And okay. So that's what it's done. So I need to push this further. So I'm going to make line 2 before starting at 2. Where would we start? Starting at 2, so I'm going to make it 4. This one's the bottom one. No, yeah, this one's the bottom one. This one needs to be 32. Then we're going to see what happens then. Almost fine. I'm going to stop this in 15 minutes. But the good thing is I've got a bit more progress on this now, which is what I wanted. Got 6 here. I'm just trying to see what that would do. That should be the top line. That is the top line. Push that to 8. Push this to 6. That does. It is the problem is getting things the other way around. It can be a little confusing. So Start off at 6. That's the bottom one. Hang on. So that was the bottom one. Just having a look at my image. I'm gonna find it. One. The bottom one is further in. Bottom one's further in. Then the next line is the top line. But oh no. Right, no, it's only one side. So this side is okay. This side needs to reflect this side in a way. That one that way. So actually I'm doing that wrong. So we can go back to 30, 30, 30. Believe. Yeah. But as I recall, this goes to here. Sorry. As I remember rightly, this goes to here and stops there. That goes to there and stops here, so that completes that one. This and this. This goes to here and this goes to the top. So their ending position is going to be smaller anyway. But so actually no, I am correct. It's got to be outside it. Right, okay. Let me see. 34 now. So we're almost there. So let's stick that to 5. I'm gonna go 40 on this one. And there you go. So I'll run this for you again. So like that. Okay, so that's a bit better. I need these lines coming down. These only go across and down. I need some that go, I believe it goes that way, and then this way, this way. This is probably why I did the array. So then I can increment the array and go, right, that's your next position to stop at. Which is why I did it that way, I think. Now I remember now. So, you know, top right, bottom left. Yeah. Right, well, okay, so I've spent an hour, an hour and a half on this. I didn't realise it was an hour and a half. But I've got a bit further. People are probably going to look at the code and go, God, man, that's disgusting. But to be fair, this is my third assembly project, and I've done a couple of Z81s. Well, I'm doing a second Z81, and I've played around with tutorials for Mega Drive and Amiga for the M68K. So I think the good thing about me doing this anyway, it gives me that kind of look into getting used to assembler code, which is what I wanted to do anyway. But yeah, I hope this I know it's been a bit different, but it's something I needed to get back on with, because I've been saying I was going to get on with this, and you know, I can now say that I did do it. So, well, a bit more of it. So I need to, next time I need to push these down. I don't know whether I'm going to do a live stream of this again. I just needed the kick, so that's why I did it. I was also watching YouTube Modern Vintage Gamer, and I know there was coding stuff, and I thought, you know, sod it all. You know, it gave me the kind of kick to do it, so that's why I'm doing it. But yeah, until the next stream and video, I will see you then. Bye.